So we want to take a look here at the x and y intercepts of a line. So first thing we're going to do is define what are the x and y intercepts. All right, so the x-intercept is the point where the line crosses the x-axis. So we can sketch a little coordinate plane here for ourselves. So we have our x-axis and we have our y-axis. And if I have a line coming through here, all right, then this guy right here, that point right there where that line crosses the x-axis, that's our x-intercept right there. Okay, so the x-intercept has a couple unique things about it. So it is a coordinate point. On the x-axis, our y value is always 0. So for any point along the x-axis, your y value is always going to be 0. And then this is just a random line, so we don't know that value, so we can just call it x. It's some x value. We don't know what it is yet. Okay. So similarly, the y-intercept is the point where the line crosses the y-axis. So on this line, that happens down here on the kind of negative portion of our y-axis. And we had kind of discussed before when we were looking at slope-intercept form that the y-intercept will always have a value of 0 for x because we're laying on the y-axis. And it'll just be some y value for y. We don't know, this is a random line. We don't have an equation or any values on this coordinate plane. Now, one thing that's nice is if we are in slope-intercept form, right, so y equals mx plus b, we can tell the y value of our y-intercept there from that b. So you can recall that the y-intercept is always 0, b, when we're in slope-intercept form, so only when we're in slope-intercept form. Okay, so let's see how we can go about finding some of these intercepts or both of these intercepts from some equations here. Okay, so no matter what form we're in, the process for finding our intercepts is going to be the same, because depending on what intercept we're looking for, we're always going to know that the other value is 0. So if we're looking for the x-intercept, y is 0. If we're looking for the y-intercept, then the other guy, x, is 0. So let's start here with number 1, and we're going to find our x-intercept first. So to find our x-intercept, we are going to let y equal 0. So that means anywhere I see a y, I'm just going to substitute in 0 instead. So here we're going to have 0 minus 2 equals negative 2 times x plus 5. So we just need to then solve for the x. So we're going to combine any like terms, we're going to distribute and simplify, and then we're going to solve. So 0 minus 2 is negative 2. And then over here, I'm going to distribute, right? So this is going to be negative 2x minus 10. And we're going to keep solving. So we're going to add 10 to both sides. We're going to get that 8 equals 2x. And then we're going to divide both sides by 2. We're going to get 4 equals x. Now, that's not my x-intercept. That's just the x value of the x-intercept. Oops. I lost a negative there, so it should be a negative 4, sorry. That's just the value of x in the x-intercept. The whole x-intercept is the point negative 4, 0. So it's really important to remember that intercepts are points. They're not a single value. They're a coordinate point. All right, so now we found our x-intercept. So now let's go about finding our y-intercept. All right, so we're going to do this in a very similar way. Because just like before, looking for our y-intercept, we said, hey, the other guy, y is 0. Now, for our y-intercept, the other guy, this time x, is going to be 0. Okay, so let's go ahead and look at what that's going to be. So this is my y-intercept. So everywhere I see an x this time, I'm going to let it be 0. So we have y minus 2 equals negative 2 times 0 plus 5. All right, so that entire right-hand side is something you can just put into the calculator. 0 plus 5 is 5, times negative 2 is negative 10. So you have y minus 2 equals negative 10. We're going to add 2 to both sides. we're going to get y equals -8. So again, this is only the y portion of the intercept. We do need to write the full thing as a coordinate point. We said, hey, x was 0. That's where we substituted in up here. And we just found that y is -8. Now let's do that for some other forms. It's going to work in a very similar way, right? We're going to do this in a very similar way. It's just going to look a little bit different in each form, okay? So here, we're going to find our x-intercept for number 2. So anytime we're finding our x-intercept, that means the other guy, y, is going to be 0. So everywhere I see a y, just substitute in 0. I'm going to draw a line here to kind of section this off. Okay, so you have 2x plus 3 times, there's a y, so I'm going to plug in 0, equals 12. So let's simplify this. 2x, 3 times 0 is just 0. Anything plus 0 is just itself, so on the left-hand side, I just have a 2x left. And divide both sides by 2 to find that x equals 6. Okay. Now to finish, I need to write it as a coordinate point. We said, hey, y is 0, and we just found x is 6. Perfect. Now, let's do the y-intercept. Okay, so this time x is equal to 0, so it's always the other variable. So now we have 2 times 0 plus 3y equals 12. All right, well, 2 times 0 is just 0. 0 plus 3y is just 3y. Divide both sides by 3, and we get y equals 4. Finishing that off to write as a coordinate point, and we get 0, 4. And I just realized I wrote my other coordinate point backwards. My apologies for that. X is the first spot in a coordinate point, so this should be 6, 0, not 0, 6. Let's double check I wrote the other one right. Yep, I did. Okay, good. So let's go on to our next one. So that was number 2 there was in standard form. Number 3, this is in slope-intercept form. Again, the process is going to be the same, but we will be able to take a shortcut the more familiar we get with this. So let's find our x-intercept first. That means y is going to equal 0. So we're going to have 0 equals 4x minus 10. It's okay that there's a 0 on the left-hand side all by itself. 0 is a number. It's a value. We can have nothing of something. We're just going to solve for x. So adding 10 to both sides, we get 10 equals 4x. Dividing both sides by 4, we would get 10 over 4. Reducing it, that would be 5 halves. It's fine to get a fraction. It happens. All right, now we have x. We can write it as a point. 5 halves, 0. Okay, now let's find the y-intercept. So this is where x is going to equal 0. Now I'm going to actually find the y-intercept before solving it because we can. But I am going to solve it too because you can do it either way. And it's nice to be able to solve for it even if you forget the shortcut. So we want to remember here that we're in slope-intercept form, right? Y equals mx plus b. And then in slope-intercept form, our y-intercept is always 0, comma, our b value. Okay, so I'm going to go ahead and just predict my y-intercept before doing any sort of arithmetic at all. And I'm going to say, all right, well, it's going to be x is always 0 for the y-intercept, and my b value here is a -10. So I'm going to say that's probably what my y-intercept is going to be, but let's check our work. So let's plug in 0 for x. Y equals 4 times 0 minus 10. Okay, well, that's really y equals 4 times 0 is just 0. So 0 minus 10. And 0 minus 10 is a -10. So yep, the y part was -10. Right, so we're just going to do that same thing and go through a few more examples just to make sure that we're all comfortable finding this with the different forms. Okay, so we're going to find the x-intercept here. So that means we're setting y as 0. So we have 3 times x minus 4 times 0 equals 10. All right, well, 4 times 0 is just 0. Right? 3x minus 0 is just 3x. So we have 3x equals 10. Divide both sides by 3. X equals 10 thirds. Remember, fractions are okay. We're just going to leave them as fractions. We don't want to be rounding. So we have 10 thirds, 0. Now finding our y-intercept, this time we're going to let x equals 0. So 3 times 0 minus 4y equals 10. That's just 0. So we have negative 4y equals 10, or y equals a negative 5 halves. So just make sure you're always reducing as much as possible. Last step is to write it as its coordinate point, 0, negative 5 halves. Okay, last two. So we want to find the x-intercept. So we should have 0 for y equals 1/2 times x plus 6. We're going to subtract 6 from both sides. We're going to have negative 6 equals 1/2 x. Divide both sides by 1/2 or multiply by the reciprocal 2/1. We'll get negative 12 equals x. So our coordinate point would be negative 12, 0. Okay, and last one, the y-intercept. This one we don't have to do any real arithmetic or algebra for because there's our b value. So we can just grab it right off the start. X is always 0 for the y-intercept, and our b value was 6. And that tells us our y-intercept because we're in slope-intercept form, so we can just quickly pull that out. All right, last one, point-slope form. X-intercept first. It doesn't really matter which one you find first. I just find the x-intercept first by default for some reason. All right, so we're going to make y 0. So we have 0 plus 2 equals 2/3 times x minus 4. Okay, so we're going to have to do a little bit of distribution, a little bit of combining like terms here. 0 plus 2 is 2, and we're going to distribute our 2/3. We'll have 2/3 x minus 8/3. Okay, so this one we're going to get a little bit of some more interesting fractions to work with. So I'm going to go ahead and add 8/3 to both sides. So that's going to get me, let's see, 14/3 equals 2/3 x. Multiply both sides by the reciprocal 3/2, or go ahead and divide by 2/3. They'll get you the same result. And when we do that, we get a very nice integer value, 7 equals x. So our coordinate point here for the x-intercept would be 7, 0. All right, now let's go about finding the y-intercept. Okay, this time we're going to let x be 0. So we'll have y plus 2 equals 2/3 times 0 minus 4. Okay, so you can just take that whole right-hand side, plug it into your calculator, and we're going to get y plus 2 equals negative 8/3. We're going to go ahead and subtract 2 from both sides. We'll get y equals negative 14/3. So again, just leave it as a fraction. If we wrote this as a decimal, it would be a repeating decimal and we'd have to round, and we'd rather leave it as an exact value. So last step, rate it as a coordinate point, 0, negative 14/3. So that there is 6 examples there of finding the intercepts, both the intercepts in all 3 forms of an equation of a line.